Hi, in this video we are going to implement the in-order traversal together. And basically the in-order traversal for integers is going to return the numerical ordering. If we store, for example, strings, then it's going to return the alphabetical ordering. Okay, so what is the in-order traversal again? We just visit the left subtree, then the root node, and the right subtree in a recursive manner. So the left subtree, then the root node, and the right subtree. But the left subtree again contains a root node, a left subtree, and a right subtree. So we just have to use the same approach over and over again in a recursive manner. Okay, like this. So basically we will visit 1, then 10, 16, 19, 23, 32, 55, 79. Which is going to be the numerical ordering in this case. Okay, so how does it look in Java code? We just have this tree interface with the traversal method. So in the traversal method, we're just going to check whether if the root node is not equal to null, we are just going to make an in-order traversal. Anyways, of course, there's no need for an in-order traversal because the tree is empty, because the root is null. Okay, so I'm just going to create this private method, and here the implementation is quite straightforward. Sorry for that, we have to start at the root node again in a binary search tree, and basically any other tree-like structure, we can access the root node only. So we start at the root node as usual. I'm just going to call node. If the node.getLeftChild is not equal to null, we're just going to call this in-order traversal in the left subtree. Because in an in-order traversal, we visit the left subtree, then we visit the root node. And I'm just going to print out this node, for example, without a new line character, plus some spacing, and then we have to visit the right subtree, so get right child is not equal to null. Of course, if the right subtree is null, we don't have to visit it. We just have to call this in-order traversal on the node.getRightChild. Okay, I'm going to get rid of this just to be consistent because I used it like this in the left subtree. And basically that's all about the in-order traversal. We visit the left subtree, then we print out the root node, this node basically, and then we print out the right child, so the right subtree. It's very important that this root node, I said that we print out the root node. It is not always this root node. It may be the root node of the subtree. So we have the root node and we have a left subtree, and in the left subtree there's a root node. Okay, maybe the left subtree of the left subtree again is a tree-like structure, so this is why we have to use recursion. Okay, so let's save it, and in the app.java I'm just going to have a bst.traversal. And okay, I hope that it's going to yield the numerical ordering. -22, -1, 0, 1, 10, 1000. 1, 2, 3, 4, 5, 6 items. 1, 2, 3, 4, 5, 6 items we have inserted. So basically it's working fine for integers. Let's suppose the fact that we would like to store, for example, strings, names, Adam, Joe, Michael or Michelle, I'm not sure to be honest. Then we have the Kevin. Then we have the whatever stuff. Then the Daniel. And I would like to get the in-order traversal, which is in this case for strings, it should yield the alphabetical ordering. Adam, Daniel, Joe, Kevin, Michael, and stuff is going to be the alphabetical ordering. So it's very important that for a tree-like structure, such as a binary search tree, we are able to get the in-order traversal, which is going to yield the numerical ordering for integers and the alphabetical ordering for strings and characters. So we are able to make the order in this case. It's very important because we are going to consider other data structures, such as, for example, hash tables and maps. And these data structures do not support the sorting operation. And that's why more advanced data structures came to be, such as tries and ternary search trees and so on. So this sorting operation is a crucial feature for a tree-like structure, and this is why we like tree-like structures, because we are able to implement lots of features, including the get min, get maximum value, removal operation, insert operation, and it has the order, which means that it's going to yield the numerical ordering or the alphabetical ordering. Thanks for watching.